Hello everyone, today we will solve the Chemistry NEET 2020 Model Question Paper 2. Already we have discussed one of the model question paper for NEET 2020. So in today's video we will solve the second model question paper of Chemistry NEET 2020. So let us go to the 46th question. As I have already told you that from first question to 45th question, the questions will arise from the subject physics, and from 46 to 90 you will get the questions from chemistry. So the first question of chemistry starts from 46th. Therefore I have considered the 46th question, that is the observed osmotic pressure for a 0.10 m solution of FeNH4 twice SO4 twice at 25 degrees Celsius is 10.8 atm atmospheric pressure. The expected and experimental values of Van 't Hoff factor I will be respectively. So given R is equal to 0.082 liter atmosphere per Kelvin per mole. So how to solve this? Here, as you know that the value of I is nothing but the observed value and normal colligative property value. So here they have given one of the colligative property, that is osmotic pressure. So here you have to mention the osmotic pressure, observed osmotic pressure and normal osmotic pressure. So what they have given, the observed osmotic pressure of this solution will be 10.8 atmosphere. So pi observed is equal to 10.8 atmosphere, because as you know the osmotic pressure is denoted as pi, which is observed value is 10.8 atm, and pi normal, okay, that is normal osmotic pressure will be how much? How you calculate? CST, okay, concentration, temperature, and this is R, okay. So here, sorry, this is R, that is universal gas constant. So how much you will get? 0.082 into R value is given. So substitute the value of C, R and T. So what is the value of C? That is concentration, that is having the molarity 0.10 into R value is given, that is 0.082 into temperature is 25 degrees Celsius. Convert that into Kelvin, you will get 298. So upon multiplication you will get the answer 2.446. that is the normal osmotic pressure, and this one is observed osmotic pressure. So I is equal to observed osmotic pressure divided by normal osmotic pressure. Substitute the values, what you will get? 10.8 divided by normal osmotic pressure is 2.446. So upon solving you will get 4.42. So which option is right here? Option A. They have asked expected and experimental value. So here the experimental value that you have calculated, that is 4.42. Among these four options, the 4.42 is present only in option A, and hence there is no need to find the expected value, that is 5. And if you want to find the expected value, just simply observe the formula. How much you will get? This compound will get dissociate into Fe ions and ammonium ions and sulfate ions. So sulfate ions, how much you will get? 2 sulfate ions, 2 ammonium ions and 1 Fe plus ions. So totally 5 ions are produced, and hence you can say that I value would be 5. So that is expected. By simply observing the formula of the compound, you can say the expected value of I, that is 5. Okay, so 1 plus 2 plus 2. So totally 5 you will get. And when you calculate that experimentally, you will get 4.42. Therefore, option A is the correct one. Next, 47th question. In Freidel Craft's acylation reaction, the effective electrophile is. So when you observe the Freidel Craft acylation reaction, so it can be given as RCOCl plus AlCl3. What it gives? It gives AlCl4 minus, okay, it is a nucleophile, plus RC double bond O plus. So this is the electrophile that you get during the Freidel Craft's acylation reaction. Therefore, here the correct answer would be RCO plus, that is option D. And 48th, match the columns. In column 1 they have given certain properties of the element, and in column 2 they have given the elements. So lanthanide hard as steel. Okay, this is one of the theory based question. So simply if you know the theory, then you can answer this one. So lanthanide hard as steel, which one it is? You already know it is Sm, samarium. And lanthanide with maximum, so this is R is A. Then lanthanide with maximum paramagnetic character in Ln plus 4 state, it would be europium, that is option B. Okay, and then lanthanide with the maximum value of E0 for reaction, okay, electrode potential for reaction for this Ln plus 3, which takes 3 electrons and becomes Ln, it would be Tb. Okay, that is C. And option D, lanthanide whose Ln plus 3 ion is diamagnetic in nature, that is lutation. So which is D. So which one is the correct answer here? A, R, B, S, C, Q, D, P. So when you observe these options, the option D, here you can get A, R, B, S, C, Q and D, P. So option D is the correct one. 49th question. Specific volume of cylindrical virus particle is 6.02 into 10 raised to minus 2 cubic centimeter per gram, whose radius and length are 7 angstrom and 10 angstrom respectively. If Na, that is Avogadro number, is equal to 6.02 into 10 raised to 23, find the molecular weight of virus. So here you need to find the molecular weight of virus. So before that, first write down what they have given. This specific volume, okay, specific volume means the volume of 1 gram of virus. When you take the 1 gram of virus, how much volume it will occupy, that is known as specific volume. So that specific volume of virus, which is cylindrical, is how much? 6.02 into 10 raised to minus 2 cc per gram. Then radius, okay, radius will be how much? 7 angstrom. Okay, that is 7 into 10 raised to minus 10 meter. Or here, since it is given in gram, the volume is given in gram, convert that into centimeter. How you will convert? Multiply it with 100. Okay, so what you will get? 10 raised to minus 8 centimeter. Okay, that is the radius of virus. Then length is also given. Whose length? Length of virus. Okay, that is how much? 10 into 10 raised to minus 8 centimeter. Here they have given 10 angstrom. So 10 into 10 raised to minus 10 meter, and when you convert that, you will get 10 into 10 raised to minus 8 centimeter. Then volume of virus. They have given specific volume, but here you need to find the volume of the virus. So the virus having the radius this much and the length this much has how much volume, that you need to find. So since it is cylindrical virus, the volume of cylinder can be calculated as pi r square L. Okay, pi is 3.142 into how much? That is r square is 7 into 10 raised to minus 8 whole square into length is 10 into 10 raised to minus 8 centimeter. So upon simplification, what you will get? You will get 154 into 10 raised to minus 23 cc. This is the volume of the virus. And here what you need to find? You need to find the molecular weight of a virus. Therefore, you should know here weight of one virus particle. Okay, weight of one virus particle, it is calculated by volume divided by specific volume. So remember this, the weight of one virus is equal to volume divided by specific volume, weight of one virus. But what you need to find? You need to find molecular weight. Then what do you mean by molecular weight? Molecular weight means sum of atomic masses. But here you need to consider the sum of all the particles. So how many particles will be present in 1 molar mass? There it represents the Avogadro's number. So here don't write it. So weight of one virus, volume divided by specific volume. But molecular weight of virus, it would be equal to how much? Volume divided by specific volume into Avogadro's number. It gives the molecular weight of virus. So substitute the values. So volume is how much? 154 into 10 raised to minus 23 divided by specific volume is how much? Already they have given, that is 6.02 into 10 raised to minus 2 into Avogadro's number 6.02 into 10 raised to 23. So on simplification, you will get 15400 gram per mole, or you can also write it as 15.4 kg per mole. Okay, so this is the answer. Here they have given the answers. So the correct option is option D, 15.4 kg per mole. So remember this. Next, 15th question. Arrange the following in increasing order of their acidity. Orthocresol, salicylic acid, that is named as B. Phenol is named as C. Now first write down the structures. If you know the structures, you will easily get the answer. So orthocresol, it can be written as OH CS3, ortho position. It is present at ortho position. So orthocresol. Then next one is salicylic acid. How you can write it as? It can be written as OH COOH. This is salicylic acid. And third one is phenol. Structure of phenol can be represented like this. So this is A, B, C. Now which one is having the greater acidity and which one is having the lesser acidity? So here remember the electron releasing groups like CH3, okay, as well as OCS3, okay, and NCS3. Such type of presence of electron releasing groups increases the negative charge of phenoxide ion. So when it intensifies the negative charge of phenoxide ion, it destabilizes it and hence decreases ionization of parent phenol, okay, and hence it decreases the acidity while electron donating groups and increases acidity, okay. So electron releasing groups, they will decreases the acidity. So electron releasing groups, they will decreases the acidity, okay, and electron withdrawing groups, they will increases the acidity. So here electron withdrawing group increases acidity, and hence those groups are NO2, COOH, okay. So you know already these groups, presence of these groups increases the acidity of the compound. Therefore, among these, which option is the right one? So see here, orthocresol, electron releasing group is there, okay, but in other cases electron releasing group is not there. So which one is having the very less acidity? So since they have asked you to calculate or arrange the following compounds in the increasing order of their acidity, so first you have to write the compound which is having lower acidity or less acidic, that is orthocresol. How we can name it as A. It is having less acidity than which one? So COH group is present in salicylic acid and hence it will increases the acidity. But here there is no electron releasing or withdrawing group and hence it is a simple phenol which is slightly more acidic than orthocresol, and hence A is less than C and C is less than B, because B is more acidic due to the presence of COOH, and hence we can arrange these compounds in this manner. A is less than C is less than B. So which option is right here? Option D is the right one. 51st, consider the following statements. The radius of an anion is larger than that of the parent atom. Okay, is it right? The radius of an ion is larger than that of parent atom. So this is right statement, because as you know, when they take the electrons, the anion will be formed, and due to the electron repulsion in the outermost shell, the size of the ions gets increases, and whereas cation size decreases. So the first statement is right one. Then second one, the ionization energy generally increases with increasing atomic number in a period. So is this the right one? Ionization energy generally increases with increasing atomic number in a period. So when you consider different atoms, so when atomic number increases along the period, so if you consider Na, okay, after Na which atom you will get? Mg, Al. So as we move along the period, the ionization energy for Na is very less, whereas ionization energy for Mg is more, and ionization energy for aluminum is still more. So as we move along the period, the ionization energy increases. But when we move down the group, for example, if we consider K, potassium, its ionization energy is lesser than sodium. Therefore, along the period, ionization energy increases. Down the group, ionization energy decreases. So hence the the second statement is also the correct one. Then third one, the electronegativity of an element is the tendency of an isolated atom to attract an electron. So electronegativity of an element is the tendency of an isolated atom to attract an electron. So is it right on? No, because electronegativity is nothing but it is the tendency of an atom in a compound to attract a pair of bonded electrons towards itself. Okay, but what they have given here? Tendency of an isolated atom to attract an electron. No, it is the tendency of an atom in a compound to attract the electron of an other atom. So suppose if I consider CCl, okay, here the Cl will attract the electrons from the carbon, okay, and this ability of an element is said to be electronegativity. Okay, and hence the electronegativity of element is not a tendency of an isolated atom to attract an electron. This option is wrong. Therefore, among these three statements, the first and second statements are right. So which option is right here? 1 alone, 2 alone, 1 and 2, 2 and 3. So first and second are right, and hence option C is the right one. 52nd, Cl2 changes to Cl minus and ClO minus in cold NaOH. Equivalent weight of Cl2 will be, so here we can write the reaction, that is Cl2 plus OH minus. So when it is treated with sodium hydroxide, it will form Cl minus plus ClO minus. Chloride ion and perchloride ion. Now I will consider half Cl2. It gives Cl minus plus ClO minus. Here see the oxidation state. Oxidation in Cl2 is 0 and here it is -1, and here oxidation change will be 1. Okay, because in Cl here it is 0 initially, but after that the oxidation state becomes -1. So overall its oxidation changes to 1 unit. It may be minus or plus. Okay, so 1 oxidation change will be observed. Therefore equivalent weight or equivalent mass of Cl2 is in reduction Hoff reaction. Okay, so equivalent mass of Cl2 in reduction Hoff reaction is equal to, how you can calculate, half Cl2 divided by 1. So how much you will get? M divided by 2. Okay, so next consider half Cl2, which gives Cl minus plus ClO minus, again Cl minus and ClO minus, and equivalent mass of Cl2 in oxidation Hoff reaction. Okay, so oxidation Hoff reaction, when you consider, again we will write half Cl2 divided by 1. So how much you will get? M by 2. Therefore equivalent mass in overall reaction, how much it is? Equivalent mass for overall reaction. Okay, this is reduction and this is oxidation. So here 1 unit changes, here 1 unit changes. When we consider this reaction, it will be M by 2, and for oxidation Hoff reaction, it is again M by 2. So equivalent mass for overall reaction will be M by 2 plus M by 2 is equal to M by M. Sorry, it is equal to M. Therefore option A would be the right answer. 53rd, take out the wrong statement. Option A, nitrogen has ability to form pi bonds with itself. It is the right statement, as you all know. Okay. Then option B, bismuth forms metallic bonds in elemental state. This is also the right statement. Option C, catenation tendency is higher in nitrogen when compared with other elements of the same group. So this one is the wrong, because here the catenation means it is ability to form chain or linkage with its atom, and when we compare this nitrogen group, okay, so 7, then phosphorus will comes, that is 15. Okay, when we compare this catenation tendency, the phosphorus is having higher catenation tendency as compared to nitrogen, and hence phosphorus is having higher catenation tendency but not nitrogen. So this is the wrong statement. And option D, nitrogen has higher first ionization enthalpy when compared with other elements of the same group. This is also the correct statement. So option C is the wrong statement, and hence it is the correct answer. Okay, the correct answer for this question will be option C, because they asked you to pick out the wrong statement. So option C is the right one. 54th, in the conversion of Br2 to BrO3 minus, the oxidation number of Br changes from, so write the reaction, Br2 gets changes to BrO3 minus. So what is the oxidation number in Br2? It is 0, and here the oxidation number will be plus 5. Okay, so here how you calculate the oxidation number? You have to calculate the oxidation number of Br. So let us consider this one as X plus oxygen atoms, 3 atoms are there, and its electronegativity will be -2. Therefore here it is -1 overall charge. So how much you will get? X minus 6 is equal to -1. So X is equal to -1 plus 6. How much you will get? X is equal to plus 5. Therefore the oxidation state of Br is plus 5. Thus it changes from 0 to plus 5. So which option is right? Option A is the right one. 55th, arrange the following phenols in order of their increasing acidity. So as you know, all these consist of NO2 electron withdrawing groups. So all are acidic, but you have to choose which one is less acidic and which one is more acidic, since they are present in ortho, meta and para positions. So when you observe the first one, okay, so here it is stabilized by both minus I, that is negative inductive effect and negative resonance effect of the NO2 group. Okay, so it is stable, minus I and minus R, these will get stabilized. How we can write? So we can write it as, how we write? O minus, okay, and NO2, you will get this one. And when you consider the second one, that is which is present at meta position, how we can write? O minus NO2, okay, O minus NO2. And third one, how we can write it? We can write it as O minus NO2. So these are the ions which are formed. So which one is having more acidity? So it is stabilized by both minus I and minus R effect, and this one is stabilized by both that ortho minus I and minus R, but here the minus I effect which is observed in first one is less here. Okay, so this one here you can observe minus inductive effect, negative inductive effect, but it is less than the first one because NO2 group is present here only, so its tendency to attract the electron is more, and hence its minus I effect is more and its minus I effect is less. Okay, comparatively the second, this one is having lesser inductive effect, and this one, that is the second one, it is having only minus I effect, shows minus I effect. It is stabilized by minus I effect. It does not show minus R resonance effect. Okay, so hence when we compare all these three, okay, which option will be the right one? See, third one, this one, it is stabilized by minus R effect. Okay, and it is having less minus I effect, and hence we can write third is having greater acidity than the first one, and first is having greater acidity than second. Okay, so this is the increasing order of the unity of the compounds in the increasing order. Okay, so third is greater than first is greater than second. Okay, option, which option is right here? Option C. Then 56th, the average molecular speed is greatest in which of the following gas samples? So average molecular speed, how you will write the average molecular speed? Average molecular speed is equal to square root of 8 RT divided by pi m. Okay, where T and M are dependent. It is dependent on T and M, temperature and molecular weight. Thus, greater the value of root T by M, okay, the greater will be the molecular speed. Greater the T by M, greater will be, which one will be? Molecular speed. Okay, remember, molecular speed. Now consider square root of T by M. Since you know, if T by M value is greater, the molecular speed will be greater. Therefore, just simply calculate T by M, square root of T by M. Then you can easily get which one is having greater molecular speed. No need to substitute 8, R and pi values. Okay, so root T by M. So for first, that is O2, 1 mole of O2 at 560 Kelvin. So temperature is 560 and the molar mass is how much? 32. O2 is 32. Oxygen is having 16 and 2. Since it is O2, so its molecular mass or molecular weight is 32. So how much you will get? You will get 4.18. And for second one, neon, this is for O2. Then second one is neon, where root T by M. So T is 500 divided by 0. Neon, its atomic mass or molecular mass is 20, and hence its value would be 5.0. And then O2, okay, CO2, which is having the temperature 440 Kelvin and molecular weight, how much its molecular weight? Its molecular weight will be 44, therefore it is 3.16. And last one, helium, it is maintained at the temperature of 140 and the molecular weight of this will be 4, that is equal to 5.91. So which option is right? Which one is having more value here? Root T by M 4.1850, 3.16, 5.91. So this value is very high, and hence its average molecular speed is greatest among these gas samples. So option D is the right one. Next, 57th. Aniline is an activated system for electrophilic substitution. The compound formed on heating aniline with acetic anhydride is. So how we can write the structure of aniline? Aniline, say benzene ring and NH2. This is the structure of aniline. Now, when it is treated with acetic anhydride, that is nothing but CS3, C double bond O, O, C double bond O, CS3. This is acetic anhydride. When it is treated with acetic anhydride, it will form NH, C double bond O, CH3 plus CS3, COOH. It is acetic acid. So which compound will be formed here? NHCOCH3. So option, which one is right here? Option D is the correct answer. 58th, the formula mass of Mohr salt is 392. The iron present in it is oxidized by KMnO4 in acid medium. The equivalent mass of Mohr's salt is, you need to calculate the equivalent mass of Mohr salt. So what is Mohr salt? Mohr salt is given as FeSO4 NH4 twice SO4 6H2O. This is the molecular formula of Mohr salt. Okay. Now Fe plus 2, it is present in it, it is oxidized to Fe plus 3. So Fe plus 2 gets oxidized to Fe plus 3. So what we have? Fe plus 2, when it oxidizes to Fe plus 3, what it makes? It loses 1 electron. Therefore, equivalent mass is equal to formula mass divided by the electrons lost or gained during the reaction. That we have to consider. That is nothing but 1 here. Only 1 electron has been lost. Therefore, formula mass is 392 divided by 1. So you will get 392. Therefore, the answer is option A. 59th. Sewage mostly constitutes. Sewage means it is emitting from the domestic purposes in drainages. Okay, what it consists of? It consists of animal waste and plant waste. So it simply consists of biodegradable pollutants. Okay. If we consider industrial effluents, it consists of non-biodegradable effluents or pollutants. But sewage, domestic sewage usually consists of biodegradable pollutants. So option B is the right one. 60th question. The Langmuir adsorption isotherm is deduced using the assumption. So there are two adsorption isotherms. One you have already learned, that is Freidel adsorption isotherm. Okay, and another important adsorption isotherm is Langmuir adsorption isotherm, and it is deduced to overcome the Freidel adsorption isotherm, which does not explain the behavior of or the adsorption at high pressure. In order to apply the equation for even for high pressure, adsorption at high pressure, Langmuir deduced an equation, and before doing that he made some assumption, and that assumption is the adsorption sites are equivalent in their ability to adsorb the particles. So option A, this one is only the right assumption. Okay, so it is the right one. So option A is the correct answer. 61st, which of the following can be repeatedly softened on heating? So which type of plastics they are which are repeatedly softened on heating? Thermoplastic. And you know another one, that is thermosetting, which cannot be softened on heating repeatedly. Okay, so such an example for thermoplastic will be which one? Option 1 C here. First one, polystyrene. This is the thermoplastic. Melamine. This is thermosetting plastic. Okay, polyesters. This is also the thermosetting polymer. Polyethylene. This is thermoplastic. Neoprene. This one is also the thermosetting polymer. Therefore, 1 and 4th are repeatedly softened on heating because they are thermoplastic. Therefore, which option is right here? Option B, because it has given 1 and 4th, those are thermoplastics. 62nd, the volume temperature graphs of a given mass of an ideal gas at constant pressure are shown below. So this is from Charles' law. Okay. Now, what is the correct order of pressures? Okay, they asked about pressures. And now, from graph, we can simply say that the correct order is P1 is greater than which one? P3, and it is greater than P2. Okay, correct order of pressure. Simply P1 is having high pressure and it is higher than P3, and P3 is higher than P2. By simply observing the graph, you can consider which one is having high pressure. So P1 is greater than P3 is greater than P2. Which option is right? Option A. 63rd, which of the following is used for making optical instruments? So optical instruments can be made with the help of silicon dioxide, SiO2. Remember this, optical instruments are most oftenly made up of SiO2, silicon dioxide. 64th, the correct order of acid strength of oxyacids is. The acid strength of oxyacids of the same halogen increases with the increase in oxidation state of the halogen. So as oxidation state of the halogen increases, the acid strength of oxyacids will also increases. So here same halogen atoms are there, Cl, 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 Cl. So simply you need to find the oxidation state. The highest oxidation state Cl will be the strongest acid, and the one with lowest oxidation state will be the weakest acid. So among these four, which one is the correct answer? So first you have to determine which one is having the more oxidation state. If you observe HClO, what is the oxidation state of Cl? +1. Okay, and here HCl2 +3, and in third one HClO3 +5 and HCl4 +7. So these are the oxidation states, and they given that correct order of acid strength. Okay, so first write down the acid with the highest strength, which one it is, oxidation state, which one is having more oxidation state or higher oxidation state, HClO4, and it is greater than HClO3 because it is having +7 and it is having +5, and it is greater than HClO2 which is +3, and HClO is 1, it is weakest acid. Okay, and it is strongest acid. So which option is right? Option C. is the right one. 65th, 25.3 gram of sodium carbonate, that is Na2CO3, is dissolved in enough water to make 250 ml of solution. If sodium carbonate dissociates completely, molar concentration of sodium ions, that is Na plus, and carbonate ions CO3 minus 2 are respectively. So what you need to calculate? The molar concentration of Na plus and CO3 minus 2 ion. So concentration of, first find the concentration of sodium carbonate. Concentration of Na2CO3 will be how much? Given mass 25.3 divided by molar mass, that is 106 into 1000 divided by 250, because it is prepared for 250 ml. So just you need to find the concentration. So what you will get? 0.955 m molarity. Okay, then concentration of Na plus will be how much? It is 0. Solution's concentration is 0.955, and when you multiply it by 2, you will get 1.91 m, because when you observe this formula, for each carbonate ion 2 sodium ions are there, hence I have multiplied here with 2. But when we consider CO3 minus 2, therefore 2 Na plus, only 1 CO3 minus 2 is there. So 1 into 0.955 is equal to 0.955 m. Okay, and hence the concentration, molar concentration of sodium ions is 1.91 and carbonate ion is 0.955. So which option is right here? Option B is the right one. 66th, in which alkyl halide SN2 mechanism is favored maximum? So when we see the SN2 mechanism, CS3Cl, you have already studied the mechanism, okay, in haloalkanes and haloarenes. There you have taken the example of CS3Cl. So methyl chloride among all options is having more tendency to undergo SN2 mechanism, okay, and when we consider CS3 thrice Cl, it is more favored for SN1 mechanism, okay, and hence the option A is the right one here. 67th, equilibrium constant K changes with temperature. At 300 Kelvin, the equilibrium constant is 25, and at 400 Kelvin, it is 10. Hence, backward reaction will have energy of activation. So here remember, K will decreases with increase in temperature. Increase in temperature, that is equilibrium constant will decreases with increase in temperature, and forward reaction is exothermic, and hence EA, that is activation energy, okay, EA activation energy for forward reaction. Consider for forward reaction EA is activation energy, and backward reaction, they asked for backward reaction, that is considered as E dash, A dash, backward reaction, okay. So activation energy for backward reaction. Therefore here it can be calculated as EA dash is equal to EA plus delta H, and thus you can say, when we see this, EA plus delta H gives EA dash. Simply it shows that EA dash is greater than EA. Then only after summing up these two values you will get EA, because it is having greater value. So which one is the correct one here? Option A equal to that of forward reaction, option B less than that of forward reaction, option C greater than that of forward reaction. So backward reaction activation energy is greater than forward reaction. So option C is the right one. 68th, which of the two ions from the list given below that have the geometry that is explained by the same hybridization of orbitals? Okay, now hybridization, how you will calculate the hybridization? Hybridization is equal to half into number of valence electrons of central atom, number of valence electrons of central atom plus number of monovalent atoms attached to it, monovalent atoms attached to it. It means central atom, number of monovalent atoms attached to central metal. Okay, now along with this minus, what you need to write? Negative charge if any. Okay, negative charge if any. First take the sum of these two and subtract if there is negative charge and subtract it if it is having any positive charge. Okay, this is the overall formula. Now see, NaNO2 minus, this is the first time. Hybridization will be Hoff. So number of valence electrons in the central atom. Which one is the central atom here? Nitrogen. Number of valence electrons is 5. Just go through the electronic configuration. You will get the number of valence electrons 5 plus number of monovalent atoms. Monovalent atoms, no, it is a divalent because O2 is attached. So 0. Then negative charge if any, one negative charge is there, so minus to minus plus 1. Okay, and positive charge if any, there is no positive charge, so minus 0. So how much you will get? Half into 6, 2 1s are 2 3s are, so 3. If you get the 3, which hybridization it is? sp2. In one of the question paper, I have already explained about the how to find the hybridization. Okay, in while solving the JEE question, I have explained about this. Okay, then NO3 minus. So similarly, what you will get? Hybridization 1 by 2, 5 plus. Okay, 0. Monovalent atoms are not there. Negative charge is there, that is 1, and positive charge is 0. So it is also 3. So hybridization is sp2. Therefore, in option 1 only, you can explain the structure of both these with same hybridization. Therefore, option A is the right one. Similarly, you can calculate for NH4 plus NO3, SCN, NH2, NO2 and NH2 minus. Okay, so remember this formula. 69th, phenol plus diazonium chloride, phenyl diazonium chloride in presence of base, what it gives? This reaction you have studied, so I will directly write the reaction. What you will get? You will get an azo dye, that is given as, it is given like this. Okay, so this is the azo dye that you will get. So which option is right here? Option A. Okay. 70. White lead is, white lead, it is nothing but 2 PbCO3, PbOH twice. Okay, which is prepared by PbNO3 twice, PbNO3 twice and Na2CO3. Okay, also it is called as basic lead carbonate. White lead, it is also known as basic lead carbonate. Okay, remember this. Therefore, which option is right here? Option C. 71st. The commonest method for the extraction of metals from oxide ores involves. So when there is a presence of oxide ores, they are reduced by using the reducing agent in presence of heat. So when we consider oxides, C is most common reducing agent. That is, melting process is used. Okay, so reduction with carbon and carbon monoxide will be the commonest method for extraction of metals from oxide ores. For some of the examples like SnO2, when it is treated with coke, then it gives Sn and 2CO. Okay, and when we consider zinc oxide, here also in the metallurgy of zinc, you have studied how it can be used as reducing agent. And in case of FeO, in blast furnace, the iron can be reduced by using carbon monoxide and forms Fe plus CO. Therefore, the commonest method of extraction of metals from the oxide ores involves reduction with carbon and carbon monoxide. Option A is the right one. 72nd. With which one of the following elements silicon should be doped so as to give P-type of semiconductor? P-type, it is obtained by adding electron deficit impurities. So electron deficit impurities examples are trivalent. Okay, trivalent atoms are examples for electrodeficit. So when you observe these three, okay, arsenic, germanium and selenium, these are all pentavalent and hence they form N-type. Okay, and when you observe boron, it will form P-type because it is a trivalent, because in outermost shell only 3 electrons are there. Therefore, option D is the right one. 73rd, IUPAC name of the given coordination compound is. Just follow the rules, you will get the answer. Triamine bromochloro nitroplatinum 4 chloride. So option C is the right one. So as you already studied the IUPAC nomenclature, just follow the rules, you will get the answer. 74th, a molecule M associates in a given solvent according to the equation M gives Mn. For a certain concentration of M, the Van 't Hoff factor was found to be 0.9 and the fraction of associated molecules was 0.2. The value of N is. So here one formula you must know, that is degree of dissociation and Van 't Hoff factor. They are related as I is equal to 1 minus alpha into 1 minus 1 by n. Therefore, substitute the values of I, n and alpha in this, you will get the answer. I is 0.9, that is Van 't Hoff factor, that is equal to 1 minus degree of dissociation or association. Since here they have undergone association, it would be 0.2. So 0.2, 1 minus 1 divided by n. Now simplify this, what you will get, 1 minus 1 by n is equal to 1 by 2. Therefore 1 by n is equal to 1 minus 1 by 2, that is equal to 1 by 2. 1 by n is equal to 1 by 2. But what we want? We want the value of n. So n by 1 is equal to 2 by 1. Therefore n is equal to 2. Which option is right? Option C is the right one. 75th, which of the following compound will undergo self-aldol condensation in the presence of cold dilute alkali? So aldehydes which contain alpha hydrogen atom on saturated carbon undergo aldol condensation. Remember this, aldehydes containing alpha hydrogen on saturated carbon atom, okay, so they will undergo aldol condensation. So among these four, which one will undergo aldol condensation? So double bond should be present. So option D is the right one. So if you consider CH3, CH2, C double bond OH. Okay. So what it will, how it can be written as HC, CH3, CHO. Okay, this is alpha. Therefore, in presence of basic medium, it will form CH3, CH2, CCH, OH. Okay, CCH3, CHCHO. This is alpha and this is beta. So here you have to consider two molecules. So you will get the answer. Hence it will undergo aldol condensation. Okay. Option D is the right one. 76th. When 1 mole of an ideal gas is compressed to half its initial volume and simultaneously heated to twice in initial temperature, the change in entropy is. So change in entropy is given as delta S is equal to NCV log E T2 divided by T1 plus NR log E V2 divided by V1. Okay. Now N is how much? N is 1. Let us consider N is 1 mole, because here they have mentioned 1 mole of an ideal gas. So N is equal to 1. Therefore what you will get? CV log E. T2 is 2 and T1 is 1. Okay. And plus N is again 1. R log E 1 divided by 2, because the gas is compressed to its initial volume. Okay, therefore it is half, and simultaneously it is heated to twice in initial temperature. So twice. So we have taken 2. Now simplify this. What you will get? CV log E2 plus R log E 1 minus log E2. So log M by N, that you can use CV log E2. So log 1 is 0. So what you will get? Minus R log E2. Therefore, what is common here? Log E2 is common. Take it out. What you will get? CV minus R log E2. So this is the answer. So log E means natural logarithm, that you can also write it as ln2, because they have given ln. Okay. So which is the right answer? Option D. 77th. If X is amount of adsorbate and M is amount of adsorbent, which of the following relations is not related to adsorption process? So option A, X by M is equal to K into P at very low pressure. So this is the correct one. X by M Kp raised to 1 by N. This is also correct. X by M is equal to K. That is also right. X by M is equal to P. This is the wrong. Therefore, option D is the correct one, because it is not related to adsorption process, and hence option D is the right one. 78th. For the reaction of 1 mole of zinc dust with 1 mole of sulfuric acid in bomb calorimeter, delta U and W corresponds to. So Zn, when it is treated with 1 mole of sulfuric acid, it will form zinc sulfate along with the liberation of hydrogen gas. So as it is taken out in bomb calorimeter, there is no expansion in volume, so work done will be 0. W is equal to 0. And this reaction is exothermic. Okay, since it has released a hydrogen gas, so it is exothermic. So some heat will be evolved which will result in the lowering of internal energy. Therefore delta U should be less than 0 because heat is evolved. Therefore delta U is less than 0, that is change in internal energy, and W is equal to 0. So which option is right here? Option A is the correct one. 79th, reactivity of hydrogen atoms attached to different carbon atoms in alkanes has the order. So first you should know on what it depends. Reactivity of hydrogen atoms depends on the stability of free radicals. Okay, and when you see this, stability of free radicals can be written as tertiary is greater than secondary and secondary is greater than primary. Okay, so therefore the option, which option is right here? Option D is the right answer. In most cases, for a rise of 10 K temperature, the rate constant is doubled to tripled. This is due to the reason that option A, collision frequency increases by a factor of 2 to 3. B, fraction of molecules possessing threshold energy increases by a factor of 2 to 3. So we can say option B is the right one because threshold energy increases by factor of 2 to 3. Threshold energy means energy required to undergo effective collisions. Therefore it increases by 2 to 3 and hence the rate of reaction is also doubled or tripled. Therefore option B is the right answer. 81st, the restricted rotation about carbon-carbon double bond in two-butene is due to. The rotation around pi bond is not possible, as you already know. If any attempt is made to rotate one of the carbon atoms, the pi orbital will no longer remain and no parallel overlap will be possible. Thus pi bond will break. Okay, if you rotate, the pi bond will break, and the presence of pi bonds makes the position of two carbon atoms. So always the pi bonds overlap by sideways. Only sigma bonds will overlap head on, and hence option D is the right answer. 82nd, which of the following colligative property can provide molar mass of proteins with the greatest precision? So whenever we are calculating the colligative property, as you have already learnt the 4 colligative properties, the molecular mass of the solute can be determined with the greatest precision by osmotic pressure. Remember this. Among 4, the most commonly used colligative property to find the molar mass is osmotic pressure. Okay, because the other colligative properties gives low values that they cannot be measured accurately and precisely. The osmotic pressure made at room temperature gives higher values and do not require heating, and hence it does not changes the nature of polymer also, and hence it gives the precise value for the molar mass. So option A is the right one. 83rd, Cyclic hydrocarbon A has all the carbon and hydrogen atoms in a single plane. All the carbon-carbon bonds have the same length, less than 1.54 angstrom, but more than 1.34 angstrom. The C-C-C bond angle will be, when we take the cyclic hydrocarbon. So let us consider the cyclic hydrocarbon. Since they have given C-C-C, so I have taken the cyclic hydrocarbon having 6 carbon atoms. So all these are undergo sp2 hybridization, and therefore C angle is 120 degree. Okay, if you consider this, it will undergo 120 degree, and it is also having angle 120 degree. So if you consider this, it will also having 120 degree, and hence the option D is the right one. 84th, the major product obtained in the photocatalyzed bromination of 2-methylbutane is. So this order of substitution in different alkanes will be given as tertiary is greater than secondary is greater than primary. Therefore, when we consider 2-methylbutane, that is CS3, CH2, CH, CS3, CH3. Okay, bromination, that is Br2 should be added. So it will form CS3, CH2, CS3. Okay, sorry, CH. This would be CH2, CH, CS3, CH2, Br. The substitution will take place at this position. Then along with this, it gives CS3, CH2, C, CS3, CS3, Br. So among these two, which one is major product? You have the order, tertiary is greater than, secondary is greater than primary. So here it is a primary, okay, and it is tertiary, and hence this is the major product and this is the minor product. Therefore, what is the name of this compound? 2-bromo 2-methylbutane. 2-bromo 2-methylbutane. So which option is right here? Option D is the right one. 85th, the reason for double helical structure of DNA in the is the operation of. So what is the main reason for double helical structure of DNA? The 2 polynucleotide chains of DNA molecules are twisted around a common axis, and the 2 chains are joined together by specific hydrogen bonds. Hence, option D is the right one. So, option D, hydrogen bonding, is the correct one. Next, 86th, among the following correct statement is: Brownian movement is more pronounced for smaller particles than for bigger particles. Option B, soles of metal sulfides are leophilic. Option C, Hardy-Schulze law states that bigger the size of ions, the greater is its coagulating power. Option D, one would expect charcoal to adsorb chlorine more than hydrogen sulfide. So among these, this is wrong, this is also wrong, this is also wrong statement. This one is the right statement and the correct answer. Brownian movement is more pronounced for smaller particles than for bigger particles. So what does Brownian movement? It is the random motion of particles. So as particles are small, they are responsible for Brownian movement. Okay, more will be the zigzag movement will be observed in the colloidal solution if the particles are smaller. If particles are bigger, then random motion will not observe to greater extent when compared to smaller particles. So option A is the right one. 87th, what is the correct order of spin only magnetic moment? of Mn plus 2, Cr plus 2 and V plus 2. Simply, if you know the electronic configuration, you can easily get the answer. Here 3d5 in Mn plus 2, you will get 3d5. How many unpaired electrons are there? 5. In V plus 2, how many unpaired electrons are there? N is equal to 3 because it is 3d3. And in chromium Cr plus 2, what is the electronic configuration? 3d4, N is equal to 4. So among these, which one is highest magnetic moment? N is equal to 5. So it comes at first place, then second, and this is at third place. So how we can arrange this one? Mn plus 2 is greater than Cr plus 2 is greater than V plus 2. So which option is right? Option C is the right one. 88. In which of the following cases pH is greater than 7? Option A, 50 ml of 0.1 m HCl plus 50 ml of 0.1 m NaCl. Just take the concentration of H3O plus ions. How much you will get? 0.1, that is concentration, divided by 2. How much you will get? 0.05. Then if you see the option B, 50 ml of 0.1 m H2SO4, 50 ml of 0.2 m NaOH. So here complete neutralization of strong acid and strong base takes place, because 1 Na, it is having the concentration of 0.2 and here it is having 0.1. Here 2 Hi plus ions are there and here 2 OH minus ions are there. So it will undergo neutralization. Okay, it is the reaction with acid and it is what? Salt. So here neutralization will not take place, but here neutralization will take place and pH is equal to 7. See, 0.1 m CH3COH and 0.1 m KOH. In this case, hydrolysis of salt takes place and CH3COOK will be formed, and salt of weak acid with strong base, and hence pH is greater than 7. And in case of D, 50 ml of 0.1 m HNO3, 50 ml of 0.1 m NH3. Here NH4NO3 will be formed. NH4NO3 will be formed, and hence the acid is strong, HNO3, but the base is weak, and hence pH is less than 7. pH is equal to 7, pH is greater than 7 and pH is less than 7. Therefore, the pH is greater than 7 in case of option C. Therefore, it is the correct one. 89th. In presence of platinum catalyst, hydrocarbon adds hydrogen to form an hexane. When hydrogen bromide is added to A instead of hydrogen, only a single bromo compound is formed. Which of the following is A? So consider option A. CH3CH2 CH double bond CH CH2 CH3. When we add hydrogen gas, it will form CH3 CH2 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 CH3. Okay, but if we add HBr, okay, what it gives? CH3 CH2 CHBr CH2 CH2 CH3. So from this only you can say that option A is the right one, because it gives a single bromo product. Okay, option A is the right one. Then last one, 19th. Which of the following statements are correct? Polynuclear hydrocarbons contains 2 or more benzene rings fused together. This is the right statement. Polynuclear hydrocarbons contain 2 or more benzene rings fused together. Okay. Then second one, polynuclear hydrocarbons have carcinogenic property. This is also the right one. It causes cancer. Option third, polynuclear hydrocarbons are formed on incomplete combustion of organic materials like tobacco, coal and petroleum. This is also the correct one. They are also produced in human body due to various biochemical reactions. So this is the wrong statement. Therefore, first, second and third are correct statements. So option D is the right one. So these are all the questions, 45 questions that we have solved from model question paper of NEET Chemistry 2020. So try to solve more and more questions and more question papers, so you will get a good score in NEET. Thank you.